In this section, we'll be learning about adding and subtracting polynomials. A polynomial is a monomial or a sum or difference of monomials. A polynomial can be added or subtracted. To add the polynomials, you're going to add the coefficients of the like terms, and to subtract polynomials, you're going to subtract the coefficients with like terms, basically. Okay, the degree of a polynomial should not be confused with the numbers of the term. For example, x cubed plus 1 is a binomial because it's two terms separated by a plus sign, but the degree is 3, not 2, because the greatest degree of any of the terms is 3. And what that means is kind of, I'll show you in a second some degrees of polynomials. Examples of monomials would be 2x, 5, and 5xy. You can see that in all of these, there's no plus signs or minus signs. With binomials, you're going to have two terms separated by a plus or minus sign. So it's two separate terms separated by plus or minus sign. In examples of trinomials, it's three separate terms divided by plus or minus sign. So 1, 2, 3, and they're separated by plus and minus signs. You can only add and subtract numbers that have the same variable and exponent. So that's the like terms. To find the degree of each monomial, you're going to add the exponents. To find the degree of a polynomial, you choose the highest degree monomial. And I know that sounds confusing, but I'll explain it in the next slide. So when we're finding the degree, you basically add up all of the exponents of each term. So for example, in this first problem, it's 5x squared, y cubed, and z. So the x has a 2, the y has a 3, and the z is assumed to have a 1. So the degree of this monomial, you're going to add those all up and get 6. So it has a degree of 6 for that monomial. Now in the second problem, we're finding the degree of a trinomial. So what you do is you find the degree of each individual monomial and you pick the highest. So, okay, here we go. So it's x squared, so we have 2 plus y cubed, well, times y cubed, so plus the 3, and the z has a 1. So this first monomial has a degree of 6. The second monomial has x to the 4th and y to the 5th. So if I add those together, that would give me 9. So this second monomial has a degree of 9. And 10x, the x just has a 1, so the degree is a 1. So basically, we found the degree of each separate monomial, and you pick the highest of all those. So the degree of this polynomial is 9. You pick the highest. That's how you do it. You do not add them up. You just choose the highest degree monomial. Determine whether the expression is a polynomial. If it is a polynomial, find the degree and determine if it's a monomial, binomial, or trinomial. All right, so the first one, it's two terms separated by a minus sign. So that is a binomial. And so what is the term? We have a 5x. The x has an exponent of 1. And the 2 does not have an x at all. So this is a degree of 1. In the second problem, we've got 3 separate terms. So that is a trinomial. Okay, let's look at the degree of this one. Let's see. Okay, the degree on the x is a 2 because it's x squared. In this problem, the x and the y both have an exponent of 1, so 1 plus 1 is also 2. The 5 doesn't have a variable, so its degree is 0. So we pick the highest degree monomial, and if it's a tie, we just say whatever that is. So this has a degree of 2. Number 3 has x over 2y. This is not a polynomial. And instead of just saying it is or it isn't, if it's not, you need to say why. So I'm going to put because you have a variable, well, there is a variable. Where do you think? in the denominator. So you cannot have a variable in the denominator. So all those rules that we learned in chapter 7 about what makes a monomial, the same rules apply for what makes a polynomial. So number 4, it says 3xy squared. Although the word poly means many, in the first slide that you saw, it said that a polynomial can be a monomial or any combined monomials. So this actually is a polynomial. It is a monomial. That's the type of polynomial it is. And the degree, we have 1x and 2y's. So we're going to say the degree is 3. Write the polynomial in standard form and identify the leading coefficient. Okay, so what it means to write something in standard form is you're going to write it from the highest exponent to the lowest exponent. And if you have mixed variables, you're going to write it with the highest variable alphabetically and then go down. So watch, I'll show you what this means. Okay, so what is our highest exponent in number 1? It would be the 6. Okay, so I'm going to write negative 2x to the 6th. Then what? Then we have plus 5x to the 4th. What's the next one? Negative 4x cubed. And then the only thing left is the 8. So the reason that this is in standard form is because I'm going from the highest exponent to down to the lowest. So 6, 4, 3, and nothing. So that is in standard form. Okay, so when it says to identify the leading coefficient, we have to, all that means is they want the coefficient in front of the highest exponent, basically in front of the variable with the highest exponent. So our leading coefficient in this problem would be the negative 2 because it leads in standard form. So you put it in standard form first, and then you can tell what the leading coefficient is. All right, in number 2, we have 2 variables. So what comes first, A or B? A does. So you're going to pick the highest A first. So we have this is negative 3a squared b, and then you look for the next a. So then we've got plus 2a, and then we're out of a's, but we do have a b, so 5b, and then we have a constant. Your constants are always going to be at the end. They're going to be, so we go alphabetically from highest to lowest, and then your constants are always at the end. So your leading coefficient in this case would be a negative 3, so you just write that. When you're adding polynomials, you just combine like terms, that's it. So in this problem, we've got 3x squared plus 5x minus 4. Now the parentheses would matter if it was a subtraction problem, but if it's an addition problem, they really don't matter that much. So you're basically adding a trinomial with a trinomial, but you're really going to only combine like terms. So I can just put plus 6x squared minus 6x minus 9. Now, there's an assumed 1 right here that you would be multiplying everything by, which is why I'm writing it separately below it. Okay, so let's combine like terms. So let's look for all the highest exponents first so that we can write it in standard form. So we have 3x squared plus 6x squared. That would give me 9x squared. Then I have 5x minus 6x, so minus x. And then the last thing is minus 4 and then minus 9. So negative 4 minus 9 would be a negative 13. So that would be my final answer. Now, I know the problem doesn't ask you, but if it did, the degree of this polynomial would be 2 because your highest exponent is a 2. And the leading coefficient would be the 9. When we find the difference in polynomials, this is a trinomial subtracting a trinomial. When we find the difference, again, we're going to combine like terms, but it's a little different than finding the sum. Watch, I'm going to rewrite the first polynomial, 8n squared plus 6n cubed minus 3n, and then minus. Now remember on the problem before this, I said this is like a 1 right here. So what you're actually doing is you're going to distribute this -1 to everything in the second parentheses. So we have minus 6n plus 4 minus 5n squared. And a lot of times my students will ask me, well, you're just changing the signs of everything. Yes, I am, because I'm multiplying that second polynomial by a -1. Now we just combine like terms. So I'm going to look for the highest exponent first, which is my cube. I only have 1. So I'm going to write 6n cubed. Then I have, let's look for anything with a square. So I have 8n squared minus 5n squared. So that would give me minus 3n squared. I'm sorry, that would be plus 3n squared. So 8n squared minus 5n is 3n squared. So that's what I would get there. And then I have negative 3n minus 6n. So I get negative 9n, and then the only thing left is that 4. So this would be my answer. And again, it doesn't ask, but if it did, my degree would be 3 because it's my highest exponent, and my leading coefficient would be the 6.